Today's lesson comes from Chapter 3, Lesson 4 on the greatest common factor, and we're going to look at 3 different methods that we can use to find the greatest common factor of a pair or group of numbers. Before we actually find the greatest common factor of numbers, it's probably important to know what that actually is. So the GCF, as it's commonly referred to, is the largest number that is a factor of a pair or group of numbers. To understand the definition, we must have a solid understanding of what a factor is. So, for review, we know that a factor is a number that divides evenly into another number with a remainder of 0. The first method we're going to look at, I like to call the factor T method, because this should strike a chord with you from one of the previous lessons we just looked at, where we created a factor T to list all the factors. And that's the goal of the factor T model. We want to list all the factors of each number and then compare our two lists to find the largest. So if we look at the number 12, I'm going to do the factor T just like I've talked about before. Set up my number. I always start at the number 1, so I'm going to put 1 and 12 on there. I'm going to move up to 2. I know that 2 goes evenly into 12 since it's an even number. And I'm going to get 6 across from it. 3, since the sum of the digits 2 plus 1 is 3, I know that 3 goes in. 3 goes into 12 4 times, and note 3 and 4 are right next to each other, so I know I can stop there. I've listed all of the factors of 12. I'm going to do the same thing for 24. I'm going to make a factor T. I'm going to start with 1 and 24. It's an even number, so I know 2 goes in 12 times. 3 is also going to go in, since 4 plus 2 is 6. The 3 goes in 8 times. I know 4 is a factor. 4 goes in 6 times, so the only number I have left to check is 5. Since my number ends in 4, I know 5 is not a factor. So this is a complete list of all the factors. Now remember, for GCF, that key part is that C, the common factor. So I want to look at what factors are common. Well, I notice that both of these have a factor of 1. Both of them have a factor of 2. Both of them have a factor of 4. Both of them have a factor of 6. And both of them have a factor of 12. So there's a lot of factors in common here. So then the next key is that word, or that letter G. And that stands for the greatest. So if I look at all of these factors they share in common, I'm going to find that 12 is the largest factor that they both share. So the GCF I would indicate as 12. We're going to try another example using the factor T method, because this is probably something you can do on your own now. We spent a lot of time looking at the factor T when we first studied factors a couple days ago. So feel free to pause the video and see if you can list all the factors and identify the greatest common factor of the numbers 16 and 20. And then when you're ready, restart the video and you can follow along as I go through how to use this method for this pair of numbers. So for 16, if I start out my factor T, I'm going to have 1 and 16. 2 goes in evenly 8 times. 3, 6 plus 1 isn't divisible by 3, so I know 3 doesn't work. And 4 actually multiplies by itself 4 times 4, so those numbers meet, so I don't need to go any further. Now if I look at 20, I'm going to have 1 and 20. 2 goes in evenly, so I have 2 and 10. 3 does not go in because my sum is just 2. 4 goes in 5 times, so 4 and 5 meet, so I know I'm done listing my factors. Now I'm going to look and see what numbers are the same. Well, I look and I notice this whole column is the same. 1, 2, 4, 1, 2, 4. Over here I have a 4 and an 8, 5, 10, 16. None of those numbers match. So the only common factors they share are 1, 2, and 4. If I'm looking for the greatest of those, I know that it's going to have to be the number 4. So my GCF is going to equal 4. The second method we're going to look at asks us to make a factor tree, which also should be familiar to us. In this method, we use factor trees to find the prime factorization of each number. Then we're going to put a square around all the factors that they share. We're going to multiply all the numbers that we squared. So we're going to use 12 and 24, which I know we just did on the other example, but that way we can see how we'll get the same answer no matter what method we use. Because the goal of this is you're going to get to see 3 different methods, and then at the end you're going to choose which one you like the best. You can switch between different methods for different problems, or you can stick to just one, but this gives you a variety of options as you're finding the greatest common factor. So when we start with 12, I remember from the other day that when we find the prime factorization, we're using a factor tree, we're going to put branches off. The numbers I choose I want to be factors of 12. So if I put 3 and 4 here, I know that 3 times 4 gives me 12, so that was a good branch. 3 I remember is a prime number because the only things that go into it are 1 and 3, so I'm going to circle that. 4, however, is not a prime number. I can do 2 times 2 to equal 4, so I'm going to add those branches. However, 2 only has the factors 1 and 2, so I'm going to circle both of those. Now for 24, I'm going to do the same thing and make a factor tree. So I'm going to start off with 4 times 6, which I know gives me 24. 4 is not prime though, it's an even number, so I'm going to separate it into 2 times 2. 2 and 2 are both prime numbers, so I'm going to get rid of those. 6 is also even, so I know it has a factor of 2, so 2 times 3 will give me 6. 2 is prime, and 3 is also prime. Now the next step says to put a square around all the factors that they share. So notice there's a 3 here. The reason that I say square them is because we already are used to putting the circles around prime numbers, so using a different shape is going to help us make sure we choose only the numbers that they have in common. Now I have 1, 2 here, and I have 1, 2 here to match up. I have a second 2 here, so I can match up the second 2. I can only match double numbers if there's a 1 on each side. So I have this additional 2 here, but since there's no more 2's left for me to match in 12, the 3 numbers in each, or the 3 factors from each group that I've squared are going to be the only ones I take a look at. Now it asks me to multiply all the numbers you squared. So I had a 3, I had a 2, and a 2. I'm only going to use them once. So even though I have a pair of them, the 3 over there and the 3 over here, I'm just going to count that as 1 because I have one pair. Same thing with each of the 2's. I'm going to multiply those together. If I do 3 times 2 times 2, I'm going to have 3 times 2 is 6, times my last 2, and I'm going to get 12, which is exactly what I got using the factor T method. This would be a good time to pause the video. I want you to use the factor tree method to find the GCF of 24 and 48, and then you can restart and watch as I go through this example with you. But go ahead and give it a try. Again, factor tree should be something that we're pretty used to based on our previous lesson. So if I look at 24, let's even do this differently because we just did 24 on the other one, but I could start with 3 here. So 3 times 8. 3 I know is prime, 8 is not, so I'm going to break it up into 4 times 2. 2 is prime, and then I'm going to have to move 4 and split that into 2 times 2. So I have my prime factorization of 24, then I'm going to look at 48. I can split up any one that I choose. I always think of 6 times 8 as 48, so I'm going to start there. 6 is even, I can break it up into 2 times 3. 2 and 3 are both prime, so 8 I can break up into 2 and 4. 4 I can break up into 2 and 2. So we had a number of factors on each side. Now I'm going to put a square around all the ones they have in common. So I have 1, 3 here, and I have 1, 3 here. I have 1, 2 there, and 1, 2 on the other side. I have another 2, and another 2, and I have another 2, and I have another 2. So this time I'm multiplying 3 times 2 times 2 times 2. Again, I'm only counting each one once. It's like I'm looking at the group of numbers from only one of the pairs because I have one pair of 3's. If I do 3 times 2, I have 6. 2 times 2, I have 4. 6 times 4 is 24. So my GCF is going to be 24. The last method we're going to look at is called the birthday cake method. Somehow this seems to be a favorite after we do it, so feel free to use any or all of the different methods when you get to do some practice problems. But let me show you how this works. When we do the birthday cake method, the name comes from the birthday cake shape that seems to appear when we use this method to find the greatest common factor. What I mean by that is our first step is to place both numbers under the first layer of your cake. So if you've ever seen one of those cakes like a wedding cake where it has different letters, that's the kind of cake we're making here. We make one layer of cake and we put both the 12 on one side and we put 24, our other number, on the opposite side. Again, we're going to choose a pair of numbers we already know the greatest common factor of to see that using this method we get the same answer as we have before. Now I need to find a number that divides evenly into both of these numbers. So automatically I notice that both of these numbers are even, so 2 is going to go into both of them. So I'm going to place that number next to my layer of cake, and I'm actually going to divide each number by that. So kind of looks like a division problem if I cover up the 24 part over there. So if I know I'm dividing 2 into 12, I know that 2 goes in 6 times. So I'm going to put a 6 above there. I'm also going to divide that 2 inside the 24. So 2 goes into 24 12 times. Then I'm going to put another layer of cake over those. And I'm going to see what number goes into both 6 and 12, because I'm going to repeat until there are no numbers that go into both. Well, 6 and 12 are still both even, so I know 2 goes into both. So I'm going to go 2 into 6 3 times. 2 goes into 12 6 times. So I'm going to add another layer of cake. Now I'm going to look at 3 and 6. Well, I know that 3 is a factor of itself, because every number is a factor of itself. 3 also goes into 6, so I'm going to pull 3 in front of my birthday cake. 3 goes in 1 time, and 3 goes into 6 2 times. So I'm going to cover that with a layer of cake. Now when I look at the numbers 1 and 2, the number 1, the only thing that's going to go into it is going to be 1. Well, what happens if I pull a 1 out in front? Well, 1 divided by 1 is 1, and 1 divided by 2 is 2. Notice if I use 1 as the common factor of two numbers, I'm always going to get the exact same layer of cake as I started with, and that's not going to do me any good. I could go on and do that forever and ever. So if 1 is the only common factor that we have, we're not going to go any farther. This is where we're going to stop, because there's no other numbers that go evenly into both except for 1. So then, to find my GCF, I'm going to multiply each of these numbers together. So 2 times 2 is 4, times 3 equals 12. So my greatest common factor is going to be 12, which is exactly what I got using the other two methods. If you're feeling confident with the birthday cake method, I suggest that you pause the video and give it a try on your paper. If you still want to see it again, because this is the one method that is pretty new to us, take a look as I go over the steps and how to do the birthday cake method with 42 and 21. So I'm going to start out by making my layer of cake, putting 42 on one side and 21 on the other. The first thing I notice is that they're not both even, so I can't pull 2 out, but I know that 3 is a factor of 21, and if I add 4 plus 2, that's going to be 6. So 6 is divisible by 3, so I'm going to actually use 3. If I divide 3 into 42, 3 is going to go to 4 one time, and I'm going to have 12, so it's going to be 14. And I can do 3 into 21, goes in 7 times. So then I'm going to have to add another layer of cake. Now I'm looking for a number that goes evenly to 14 and 7. Well, 7 obviously goes into 7. 7 also goes into the number 14. So I'm going to pull a 7 out. 7 goes into 14 twice. 7 goes into 2 one time. And 7 goes into 7 one time. Put my next layer of cake. Now I'm looking at 2 and 1. Again, I come to the point where 1 is the only factor of 1. And if I pull it out, I'm just going to get the same layer of cake. So I'm going to stop there. I'm going to do 7 times 3 is 21. So my greatest common factor is going to be 21. At this point, I'd like you to take a look at the rest of the problems on the worksheet. You can choose any of the 3 methods that you want. You could do them all different methods. You could keep it all the same, whatever you feel more comfortable with, to find the greatest common factor of each pair of numbers.